Hello again, everyone. Now we're going to do problem number 2. Okay, so problem number 2 has various numbers, and it begins with Timothy takes a bike ride to the local convenience store. He travels 9 meters west and 6 meters south. If he travels a speed of 2.5 meters per second, how long would it take for Timothy to get? So let's take a look at this problem, and we break it down into its components. So the first one that we look at is we have to find out what's going on with Timothy. So we're going to take a look at that problem. So here we have, again, we're going to use the same scale. The scale that we're going to use is going to be 1 box is equal to 1 meter. Okay, so using this scale, each box is going to represent 1 meter. This makes it easy for us to draw the triangle and to understand what's going on. So he first travels 9 meters west, so that means he's going to go westward. And I don't want to have the same problem that I did the last time. So we got to go west, and then we have to go south. So we're going to start here as the reference point. So this is the reference point. And again, the reference point is the point of origin. It's the point where we begin our travels. So the person travels 9 meters west. So we count 9 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here is 9 boxes. That's 9 boxes. And then 6 meters south. 1, 2, 3, 4, 5, 6. So here we have the 6 boxes south. And now we have the X and Y coordinate drawn in a graph paper. Now, without further ado, we know that the location from the reference point to the tip is going to give us the displacement of the person. Okay, so I'm just going to draw that line in case we're going to need it later. Okay, so we have that as the resulting vector. Now, here for A, it says that he travels at a speed of 2.5 meters. So let's take a look at A. So we go to A. And we have a speed of 2.5 meters per second. And the question is asking, how long would it take Timothy to get to the store and back? So here we have 9 meters, and here we have 6 meters. Now, from the last test that we took, we know that from the triangle, if we use the triangle, we know that speed is equal to distance divided by time. Now we have speed, and we can determine the distance simply by adding 6 meters. So we have distance. So we have these two variables, and what we're looking for is time. So the formula becomes time is equal to distance divided by the speed. So let's plug and chug. Time is equal to 9 plus 6 gives us 15 meters. So we got 15 meters for the distance divided by the speed, which is 2.5 meters per second. Now what we do is we take our handy dandy calculator, and we take 15, we divide it by 2.5, and we get a time of 6 seconds. So it's going to take 6 seconds to get to the store. But the question is asking, how long would it take us to go back if we travel the same distance, the same speed? So therefore, we would have to multiply this by 2, and we get, it takes us a total of 12 seconds. So it's going to take us 12 seconds to get to the store and back. Now let's go to question number B. So B is asking, if Timothy could just ride straight to the store, what distance would he have to travel? So if he can go from his current location straight to the store, what would be the distance that he would have to travel? So we're asking, what is this distance, the resulting distance? So for that, again, we're going to use that r is equal to the square root of a squared plus b squared. So we get the answer of 6 meters squared plus 9 meters squared, and we got to take the square root of that, and we get the answer. And again, we just plug and chug here, get the square root, 6 squared plus 9 squared, close parenthesis, enter, and again we get 3 in the square root of 13. If we select this button here, we get the value in decimal form. The distance is going to be 10.8 meters. Now we go to C. And C is asking, how long would it take if he could travel straight to the store? So again, we go right back to this formula again, and we're asking for the time that it took in order for him to go straight to the store. Now it's not asking how long does it take for him to go straight to the store and back. So all it is just a simple one-time calculation. So the one-time calculation winds up being that we have time is equal to the distance divided by speed. We have the distance of 10.8 meters. We divide that by time. The time is 2.5 seconds. And we take the 2, and again, we take our calculator. So it's 10.8 divided by, 2.5, and we get a time of 4.32 seconds. Lastly, we go to D, and the D is asking, in what direction would Timothy need to travel to reach the store? So we basically want to find what is the angle here. What is the angle here in order to get to the store? What would be the angle that they would have to take? And again, we use the arctan of B over A, and we get arctan B. B is the rise, which is this here, which would be 6 meters over 9 meters. And we get an answer of arctan 6 divided by 9 equals, and we get 33.6. Because of that 9, we can round that off to 7. So we get 33.7 degrees. And this is going to be south of west. So that means from the west line, the resulting vector will be 33.7 degrees south of that line. And we get the answers to question number 2.